We will now begin part 1 of the beginner course on the fundamentals of noise. The beginner course consists of 2 parts. The first part is an explanation of noise sources and examples of using EMI/EMC filters. First, let me explain the source of noise. A typical example of a noise source is noise generated by motor equipment. Conveyor lines require speed adjustments. In the front of the motor, there is a motor amplifier to drive the motor, and switching operations are performed inside the motor amplifier. This is where noise occurs in some cases. In our daily life, there are also switching operations performed inside home appliances, such as inverter air conditioners, refrigerators, and microwave ovens, which generate noise each time they are operated. Filter circuits and EMI/EMC filters are used inside these products to keep noise levels down to levels that do not affect the operation of other equipment. Next is an example of noise generated from a switch-mode power supply. A switch-mode power supply rectifies and smooths the AC voltage that is input. Then, in order to achieve the desired output voltage, the switching section switches while adjusting the on-off time, and rectifies and smooths the voltage to achieve a stable voltage, such as the desired 24 VDC. In switch-mode power supplies, noise is generated during this switching, and in some cases, this switching noise leaks into the input and output lines, causing malfunctions. Next, let's discuss the effects of noise on switches and electromagnetic switches. Noise is generated from anything called a switch. In some cases, a pulse-like noise is generated during on-off operation of switches and electromagnetic switches, leading to malfunction of control equipment. There are many industrial products that generate noise. AC servo amplifiers are a source of noise in equipment, such as robots and conveyor lines, which operate motors with high precision and speed for positioning. Air conditioners, pumps, and compressors are noise sources because of their inverter drivers, devices that control speed using motor speed. UPSs and power conditioners, which provide a stable supply of AC power, are also sources of noise because of their internal switching operations. However, these industrial products use internal filter circuits and EMI/EMC filters to keep the noise level low enough to prevent malfunctions in other equipment. Robots, injection molding machines, and semiconductor manufacturing equipment are composed of a combination of many noise-generating devices, such as AC servos and switch-mode power supplies, so the entire device uses noise suppression parts. Next, let's look at the role of EMI/EMC filters in suppressing noise and examples of their use. The EMI/EMC filter acts like a wave-dissipating block. Rough waves, representing noise in the open sea, pass through the wave-dissipating block, which acts as an EMI/EMC filter. This reduces the wave height, that is, the noise level, so that the connected equipment in the cove is only exposed to a much smaller amount of noise. EMI/EMC filters are used for the purpose of obtaining standards and CE mark self-declaration. Limits for noise generated by the equipment are specified in various standards. The types of noise generated by the equipment include conducted noise on the input line, measured as terminal voltage, and radiated noise from the device, measured as radiated field strength. Each has its own limit values established depending on the type of equipment. The EMI/EMC filter is used as a noise suppression component for conducted noise on the terminal voltage. As for where EMI/EMC filters are used, they are generally grouped together in the input line of a device and used one at a time. In addition, to reduce the impact of noise on other devices in the equipment, it is sometimes effective to put a EMI/EMC filter in front of each device. EMI/EMC filters can also be used to prevent noise from entering the equipment from the outside, and are sometimes used to ensure stable operation. Noise coming in from external input lines, or impulsive noise generated by the operation of electromagnetic contactors inside the same device may cause malfunction of control devices such as PLCs. However, the use of EMI/EMC filters at the front of control equipment can prevent equipment malfunctions. Limits for conducted noise voltage and radiated field strength vary for each of the various standards. Therefore, it is important to check the limits of the standard being acquired. The limit values vary with the noise level required by the product and the environment in which it is used. Therefore, noise countermeasures in accordance with the limit values are necessary. This concludes the first part of the fundamentals of noise for beginners. Please now watch the second part of the fundamentals of noise for beginners.